In this portion of the lecture, we'll look at a few systems that also combine proof of work with developing a cryptocurrency, but they introduce a third component, which is timestamping. Timestamping, there's a bunch of proposals, but the earliest goes back to Harber and Stornetta in 1991, and they sort of finessed their ideas in the ensuing years. And this, what I'll explain now, is sort of the latter version of it. But in their timestamping scheme, timestamping is actually a bit of a misnomer. The idea isn't that you have some object and you're going to say conclusively that it came into existence at a particular time. But what it's going to do is it's going to try and give you a sense of, a sort of fuzzy sense of when it came into existence. And it's also going to be order preserving. So if one element is introduced after another element, that partial ordering is preserved and it's undisputable. So their idea is if you have a bunch of information, data of any sort, you can think of them visually as these blocks. What they'll do is they'll define certain regions of times or intervals. So this might be every 10 minutes, for example. And so in the first 10 minutes, they spend some time collecting all the information. And then when the interval is up, what they do is they take that information and they use a Merkle tree to combine all the information into a single node that represents all the information. Okay? Then when the second 10 minutes are up and they've collected all their objects, they do the same thing. They collect all of them and they aggregate them into a single value using a Merkle tree. And they tie the node in the second interval to the node in the first interval by hashing in this representative node as well as the whole tree. Then as time continues, more blocks come in and they continue to do this and they build up this chain. Now this data structure should look extremely familiar to you because it's essentially the blockchain. Okay? Blockchain also, you have blocks and they're aggregated, the transactions are aggregated using a Merkle tree, and every block is tied to the previous block using a hash chain. The idea of Stornetta and Harber is, let's say everybody observes this block at a particular time. Once they observe that block, they may sign it to say that, yes, I saw it and I saw it at this particular time. And once you observe this block, then everything that happened before is sort of fixed. You can't go back and you can't change the ordering of any of the events that occurred before. So you don't have to pay attention to all of these blocks as they come in, but the idea is that occasionally you check in, you grab the latest value, and when you grab it, it sort of fixes all the stuff that existed before it. So let's compare and contrast this timestamping service, which looks a lot like the blockchain in Bitcoin, with the blockchain itself. So the first difference is that in a timestamping, or the only difference, is that the timestamping service, the intervals are set by some party and you trust them. So if they're going to define the intervals every 10 minutes, nothing's enforcing that they actually occur every 10 minutes. Satoshi's idea was, what if we take a proof of work? A proof of work you can use to delay things. And so what if you apply it to delaying the creation of these new entities in the hash chain? If you can delay it and you set the proof of work so it takes about 10 minutes, then you can actually enforce in a trustless manner the fact that these intervals last roughly 10 minutes. The nice idea, the really nice idea, is that if you take the Hashcash proposal for proof of work, or Satoshi's slight modification of it, and you drop it in as the hash function that's hashing all the blocks in the Merkle tree as well as the previous block in the hash chain. If you drop it in, it just works, right? They're both based on hashes, and so you can just drop it in. It preserves all the properties you need from a hash chain and a hash tree, plus it gives you the proof of work, which slows things down so that you can only add on intervals that are set by the difficulty of this problem. Now, in the timestamping service, we also mentioned that observers observe these blocks and they sign off on them. In Bitcoin, you don't need that. You don't need signatures. You don't need people paying attention. Because the blockchain is difficult to create, by looking at the blockchain, you can just look for the longest chain. The longest chain is the one that reflects the most amount of work, and you trust it because the work was put into it, not because a bunch of people said, I saw this at a particular time. Now, the bonus of using the blockchain is it also gives you a really nice way of minting cash. If you want to mint new Bitcoins, you can update, when you update the blockchain, you can include a transaction, a Coinbase transaction that creates these new Bitcoins out of thin air. And because these intervals are set for every 10 minutes, then you have a controlled mechanism for creating these currencies at regular intervals. Now, another proposal that looked at combining proof of work, timestamping with applications to eCash is called B-Money from Wei Dai in 1998. In this proposal, you have a peer-to-peer network, sort of like in Bitcoin, and they're observers. And the point is that they all maintain a ledger, but they each have, there's no global ledger like in the blockchain. They each have their own ledger of what they think everyone's balance is. What happens is if I want to create a new coin, I choose a proof of work, and it's not really specified what this would be, but I just solve some proof of work, I generate the solution, and then that's my coin. When I have the coin, I broadcast it to all the observers, and all the observers say that my account goes up by some amount based on how much work I put into minting this coin. Then if I want to transfer the money from someone to someone else, then I do something very similar to Bitcoin where I say who I am, I say what coin I want to transfer, and I sign it with a secret key that is tied to my identity so everyone knows that this transaction came from me, and I broadcast that to the network. Then people validate the signature, the observers validate it, and they update their ledger, moving the money from my account to another account. Another proposal, an academic proposal, came in 1999, and in this case, it also used a ledger-based system. It used a Merkle tree. Instead of the structure where you have Merkle trees that tie into a hash chain, they just had a huge Merkle tree. So you make a Merkle tree that represented each day, and once you had 2 days, you would create a node above it that represented weeks, and once you've run it for more than 1 week, then you would create one for months, et cetera, et cetera. So despite the differences in the structure, the properties are basically the same. What would happen is the ledger would track coins as they're created. So this is different from both B-Money and from Bitcoin in the sense that we're not using this ledger to track transactions themselves. Okay? The transactions still happen in some fashion that's offline from the ledger. All this ledger is keeping track of is what coins were issued with what serial numbers to prevent things like double spending. But they have some additional proofs using zero knowledge so that you can't trace coins as they're spent. Another similar proposal comes from Nick Szabo. He proposed a system called BitGold. And according to him, he had the idea for BitGold as early as 1998. However, he didn't get around to blogging about it until 2005. Now, the reason these dates are maybe a little interesting is that there's a minor conspiracy theory that's popularized by Nathaniel Popper, who works as a New York Times reporter and also wrote a book on the history of Bitcoin, a very good book. Aside from this particular issue, where he notes that the blog post timestamps changed after Bitcoin was released so that the BitGold proposal looks like it was written up about 2 months after Bitcoin was released. Popper's hypothesis is that Szabo is a leading contender, if not Satoshi Nakamoto himself, and he cites this as evidence of Szabo as Satoshi trying to cover up the fact that he invented BitGold before he knew about Bitcoin. Now, the problem with this is I'll explain how BitGold works, and you can decide for yourself if it's that similar to Bitcoin or not. The other problem is if you actually read the contents of the blog post, Nick is very clear about him having this idea in 1998, and he doesn't try and change those dates. So a more reasonable explanation is that maybe he just bumped the posts to the top of his blog after Bitcoin just to popularize the idea and make sure that people were aware of his similar proposal that existed prior to it. Anyways, let's take a look at the proposal itself. So in this proposal, it starts off very similar to B-Money or Hashcash. You have a user, Alice, and she takes a challenge string. She computes a moderately hard proof of work function on it to create a solution. Now, where does this challenge string come from? Well, there was somebody who created currency before her. And so what she does is she uses their solution in order to form her challenge. And after she creates her solution, someone else will come along and they'll take her solution and they'll use it as a challenge for themselves. So all these coins are tied together through a chaining of the proof of works. Once she has a solution, she broadcasts it to a network of timestamping servers. So this is a peer-to-peer network of servers that do timestamping. And probably it was originally envisioned when timestamping services were available, where companies would actually run these services where you could send them documents and they would sign off saying what time certain things were observed. So what you do is you take your solution, you combine it with your identity and a public key, and you assert what time you created the solution at, and you get all these time servers to sign off saying that they did observe it at roughly that amount of time. Once you have this object created, you can take it and combine it with the original challenge that was used to create the solution, and you can broadcast that to a different network of servers. It could be the same network, or it could be a different network. And this network maintains what's called a secure title registry. And so what they'll do is they'll take this tuple and they'll store it for future work. And if anyone comes along and wants to see this coin, they'll pull it out and they'll show that it was created at a certain time and it was signed by a bunch of timestamping services. Now let's say that Alice wants to transfer this money to Bob. What she does is she gets Bob's identification and his public key, and she creates a second type of transaction, and she specifies her original transaction. She asserts that she wants to move this transaction from her identity to Bob's identity. She lists Bob's public key, and she signs it with her private key that corresponds to the public key that was incorporated in the original transaction. And so this is what stops anybody from transferring the money other than Alice from Alice's account. Then she broadcasts this transaction to the network, and the network records it, and the whole system continues. Now, smart contracts is something else that was pioneered by SASBO that Bitcoin touches on, and other altcoins like Ethereum take to a larger extent. Smart contracts, Nick never really wrote directly about how smart contracts would work in BitGold. He did write in general about how they might work with a secure title registry, which is the primitive that BitGold uses to keep track of all the transactions. But in any case, he did a lot of writing on that aspect of digital cash as well. In both B-Money and BitGold, proof of work is used to directly mint currency. Anybody can solve a proof of work, and the solution is money itself. In the Bitcoin, the solution to a proof of work isn't money itself. It's a block that extends the blockchain. So proof of work is used to update a blockchain instead. It's not used directly to mint coins, and you'll continue to do the proof of work well after you're done minting all the coins that will exist in Bitcoin. B-Money and Bitcoin, or BitGold rather, rely on time stamping services. So they rely on basically trusting that certain people see things at certain time and they sign off on it. In Bitcoin, you actually don't really care about what time certain things were created. All you care about is the relative order, that certain blocks were created after other blocks. And the reason that you can trust that a particular blockchain that you see is an accurate one is based on the amount of work that went into creating it. Because it takes a lot of work to create the blockchain, that's what makes you trust it, not because it was signed by a bunch of entities that assert that certain things happen at certain times. So in Bitcoin, it's a really simple solution where you can just look at the blockchain and use the longest chain. Finally, when you think about the entities that make up the peer-to-peer networks in B-Money and BitGold, if these entities start disagreeing about things that you see, you're going to basically decide what the ground truth is by counting who says what, by basically taking a vote amongst these entities. But since anybody can become an entity and entities might hide behind 100 identities, then it's really hard and not very reliable to do these type of mechanisms. In Bitcoin, because they apply the proof of work to the blockchain as opposed to relying on timestampers to assert that certain things happen at certain times, then what you can do in Bitcoin instead is you can count the work that went into the creation of something as assertion of its validity, rather than relying on what a certain number of people say. So in other words, you're counting the amount of computational power that's backing some version of events, as opposed to relying on the number of identities asserting that a certain order of events occurred. B-Money and BitGold never took off. Both of them were just proposed in B-Money's case, it was on a mailing list. In BitGold, it was across a series of blog posts. Neither of them were implemented directly. And because they were blog posts and not full specifications, not as detailed as, for example, the Bitcoin white paper, and there was no code to go along with it, the blog posts sort of gloss over a couple issues that may be solvable, may not be solvable. But what happens when people disagree about version of events is something that's not explained very well or in a convincing manner. I note that B-Money doesn't really explain it at all. BitGold does refer to some academic literature on how you solve problems, so it's a little more convincing, but there's nothing like a full rationale and explanation of how it's going to resolve conflicts. The second is that once you solve a proof of work and you broadcast it, someone else might try and steal it, and then it's a foot race to see who gets to register it first. that could probably be solved by incorporating into the challenge the identity of the person who's creating the coins, but that's not explicitly mentioned. A third problem is determining how hard the proof of work should be when you mint the coins and how much that amount of proof of work is actually worth. So in B-money, every piece of currency that's created, and in BitGold as well, it may have a completely different value depending on how hard a particular moderately hard function was at a given time given the computational advancements. What Bitcoin does instead is it adjusts the difficulty as the network gets faster, or it scales it back, and it keeps everything uniform. So every Bitcoin is worth, or a fraction of Bitcoin is worth the same amount, whereas that's not guaranteed in B-money or BitGold. Different coins could be worth different amounts depending on the functions that were used to create them.